And we see on page 21, we remember this top guy, that if I give you two functions that are being added together, and I say, hey, go take the derivative, you cool with just saying, well, it's just going to be f prime plus g prime. That's just the sum rule. We've just been doing that. The difference rule, what did I forget to do? I forgot to make those minus signs. You guys, difference means subtract. So if I'm subtracting two different functions, you can just take one derivative at a time. F prime minus g prime. We did that last week. We're good to go. Today, what are we doing between them now? We're multiplying. So they've got this thing called the product rule. Don't we wish it was just f prime times g prime? Yeah. Gosh, we sure do. It's not. So all we got to do is we got to take the derivative of the first one. So the derivative of f is going to be f prime, right? You got to just multiply that by the second function, just by g. Then you've got to add to that. If I took the derivative of the first and I left the second, what do you think I need to do next?
Derivative of the second plus the first.
Ooh, not plus.
Multiply.
Very good. He's saying, all right, well, now we got to take a g prime, and you've got to multiply that by just the original, which was f.
That makes this 0.
So here's what my 1151, 1152 kids call this. They say, oh, I'm just going to call that fig plus gif.
Okay.
Where do you think they get that?
It's the f prime's the I.
Yeah, the prime is the I. They just like that fig plus gif instead of saying product rule, instead of saying f prime times g plus g prime times f. They even forget that fig plus gif is the product rule, but I'm fine with that little notation, little anagram if we want to use it. Okay, so let's go take a peek at like this function right here. Do you agree I've got one function, boop, times another function, boop? When they're being multiplied, in order to, see Beamy? In order to take that derivative, I'm going to consider this guy, I'm actually going to write it underneath it. This is the first function. This is the second function. Let's go apply that fig plus gif on it. What is f prime? Yes, that's my f prime. So I'm even going to just got to label it beneath it. Times my g. What do we need to multiply that by? Yeah, do I have to put that 8x plus 3 in parentheses?
Yes.
Yeah. That's my g. Product rule is f prime times g fig plus gif. Boom, I got to add g prime to that.
8.
It's just 8 times f.
That whole thing.
Yeah, the f function, why did I write that there? The f function is just 5x squared minus 2. Now, is anyone like, that seemed excessive. Couldn't I have just distributed this and gotten, say, 40x cubed plus 15x squared minus 16x minus 6, then done the power rule to that? Absolutely. Our answer might have looked a little different, but they would have been equivalent. I'm good with whichever method you want to use. As we are looking, so I just want to show us this graph real fast. So this is a new perspective. You guys, I want you to say this graph is f. Well, let's do it with a pen. This graph is f. And this graph is f prime. Go ahead and label that pretty prominently. I'm actually going to make mine a little bigger. This one is f of x. This one is f prime. This is going to be funky and uncomfortable for us. I just want to show us one example, not master it all. I just want us to see it for the first time. What would you say f's y values are doing here? My y values are increasing. What would you say the slope of my tangent line is doing? It's actually decreasing, and it's approaching 0, right? Okay, so if this is the graph of f prime, check this out, and people are going to get uncomfortable. This means these points are the slope values of this graph. Would you agree this started with a very steep slope, positive, and then it approached 0? What are these y values over here? Big positive?
Yeah.
What are these y values approaching? 0. Interesting. What are the slope of this function doing now? What do the slope of those tangent lines start at, would you say? 0, then they go to? Then they go back to?
0.
Check this out. Over here, don't they have negative y values? They start at 0. Negative y values. Still negative, but go back to 0. So that messed up. So this is a graph of the slope values of this function. They start at 0. They went negative, and then they went back to 0. Weird. Finally, let's go back over here. What are my slopes doing over here? They start around
0.
and then they're more positive. What are these y values over here starting at
0.
And then are they positive and getting more positive? Isn't that kind of funky? So again, we're going to see more of those, not today, but I just wanted you to see it. It kind of messes with your brain, in my opinion. Okay, let's go skip this guy. I'm over him. Let's go try this next one. When it says, hey, go find the derivative of x times the cosine of x. Don't you agree that they're multiplying two functions together here? So what I like to do is I'm like, okay, that's one function. This is another function. And they're being, okay. You guys, if we want g prime, let's just start with g prime of x first. Let's practice this product rule. I know I've got to use product rule because my two functions, f and g, are being multiplied. Boom. Let's go find f prime. Derivative of x, 1. That right there was my f prime. Times g. Close. What's g? Just g. Yeah. So we can only take one derivative at a time, right? We just did f prime times g. Then we add the derivative of g, which is g prime. Now you're ready for it. What's the derivative of cosine? Negative sine times f, which was just x. Awesome. You guys, just a reminder, when we write this x has nothing to do with this x. We cannot say negative sine x squared. This x is actually the little coefficient. Boop. So when we go plug in our pi, every x gets replaced with a pi. So instead of saying 1 cosine, what could we say? Love it. Cosine of pi. Well, let's just write it out first. Minus, are you cool if I say pi sine of pi? I just put this x out front. I threw a pi in for him, and I threw a pi in for that x. If this was free response, we're done. But let's practice. Oh, sure did. He says, why are we switching variables? Thanks, Stevie. Okay, g prime at pi. Cosine at pi. What's the x coordinate? At pi.
-1.
Beautiful. So we got g prime at pi is -1 minus pi times the sine at pi. Right, the y coordinate there is 0.
So would it just be 0?
This would just be 0.
So it's -1.
You got it. So over here, if h of x is f times g, I got to go use that product rule to take the derivative of that. Let's just go. Actually, I think that we can throw the 4 in all at the same time because we are smart people. What would the derivative of the first function be? Close. Okay, hold on. Okay, hold on. Sorry. I want to write it out before I look at the graph. Derivative of f would be f prime. And you cool if I throw that 4 in there?
Yeah.
Okay, so it would be f prime of 4. That's f prime. What do we need to multiply that by? Love it. F prime g plus g, careful, g prime of 4 times f of 4. Well done, Graham. And now we're looking at this graph, and I'm going to highlight for us. I'm going to put my f right here is the pink graph, and then I'm going to say g is the blue graph. Okay, they first want f prime of 4, which is pink. What does that mean? F prime just means they want the slope when x is 4. Well, isn't pink just a straight line? What would that slope, what would that rise over run be? It's just going to be 1, right? Yep, the slope is just rise 1, run 1 of pink. G of 4 is now the point of my blue graph when x is 4. When x is 4 of blue, do we agree my y is 1? Great. What about g prime of 4? G prime means the slope when x is 4 up 1, 2, 3 over 2. Up 3 over 2, I dig it. And f of 4 is pink graph when x is 4. Do you agree my y is 2? Let's simplify it. 1 times 1 is my 1. 3 halves times 2?
3.
Good. Final answer?
4.
Beautiful. This one, they don't give you a graph, but they give you some info. We're going to come back to that info. If they said here is g, do you agree that is x cubed times f of x. And if they want g prime, let's just start with g prime of x, you guys. If they want g prime of x, if they want a derivative, we got to go do fig plus gif. I'm going to go label this x cubed is f. This is going to mess with my brain. I'm about to call f of x my g. Are you guys okay with that? Because it's just the second function. You know what I'm saying? That's kind of funky. Okay. Because they're being multiplied, I got to use the product rule. I know the product rule is fig plus gif. Here we go. F prime. 3x squared is my f prime. Love it. Times g, which in this case is f of x. How awful. Plus, I love that you remember that plus. That's so good. So close, hold on. True, and it doesn't matter the order that we put it in. If we follow my GIF format, let's put our G prime first. It doesn't matter though. G prime would be what, Sammy? F prime of x, that's my G prime, times x cubed. And Colin had said x cubed first. That's great. I could not care less. It doesn't matter what order any of these are in because they're being multiplied. Well, we need to go, you agree they want g prime of 2. So I'm just going to go put in a 2 for all of my x's before I get too confused. Guys, if I put a 2 in right here, 2 squared times 3, 12. And then I'm just going to write f of 2, again, just because this is our first day of seeing it. If you guys want to go ahead and substitute in already, that's fine. I'm going to say f prime of 2. And if x was a 2 here, yeah, love it. And then I heard people, and again, if you don't write this step out, that's fine. F of 2, did they give that to us? Boom, f of 2 is 2. So we got 12 times 2. Did they give us f prime of 2? Love it. Final answer, 64. This one's nicer. I like it. He says, okay, they gave me f of x is e to the x times sine.
Use x times x.
Oh, derivative of x, which they don't know the chain rule yet. The derivative of x would be 1. You're going to get there.
The derivative of e to the x is...
Wait, do we feel good about this so far, you guys, that he just said f prime is e to the x? Where'd you get that, Mr. Richards?
Well, the derivative of e to the x is e to the x.
You agree? Yeah. And then where'd he get the sign?
Plus...
Ooh, he even remembered the plus.
The first, which is e to the x.
Okay.
Times cosine x.
Do we agree with that?
Yeah.
Saying the derivative sign is cosine. And he says, all right, and I got to leave my original function. He put it in your order, right, Colin? Just threw that out front. Doesn't matter. But, guys, I don't see that as an answer.
They have something in common, don't they? E to the x.
Ooh! Ooh, you guys, why do you think they put this as an option? What's the derivative of cosine? Do people get those mixed up, do you think? For sure. Our answer here is C. Mr. Richards, good memory. Okay, you guys, on your homework packet, page, let's flip on your homework packet. There's 4 questions on product rule. Page 15, 4 questions on product rule. Let's do it.